So how's it going? Good. You guys been studying chapter what? 5 and 10? Yeah. So is there a test coming up anytime soon? Yeah. When is it? This weekend. This weekend. So we are working on 10 and 5, right? Practicing those gas laws, and we're going to work in chapter 5. So we have lab today. What are we doing in lab today?
The rate of R.
Okay, gas laws. Yeah, ideal gas law. So we get to a little work, on those ideal gas law information. And okay, well, let's keep talking about chapter 5. Do you remember we left off talking about enthalpy, right? What did we learn about enthalpy? What are some things we know about enthalpy? It's a state function. Very good. What else? Okay, it is extensive. And what is it defined as? Enthalpy is equal to, what do we say? Energy plus pressure volume work. And if we are at constant pressure, what does enthalpy equal? Okay, enthalpy equals Q. You guys remember that? Enthalpy equals Q at constant pressure? Okay. All right, so that's what we've learned so far about enthalpy. So let's talk about some other truths about enthalpy that we need to know. And the first one is enthalpy is extensive. Do you guys remember extensive and intensive properties? You guys remember that? Yeah, way back. It was in chapter 1 that we talked about that. What's the difference between extensive and intensive properties?
One is measured by is it the density? And one is not, it don't depend on if it's hot, cold, or...
What? Yeah, very close. Yes, one of them. Yeah, you are so on the right track. You are so on the right track. One of them is independent of the amount that you have, okay, and the other one, it matters. So intensive, right, means independent of the amount that you have. Extensive, right. Extensive, it does matter how much you have. Okay, so like density is intensive, melting point is, but mass, you're right, is extensive. Okay, so enthalpy is an extensive property. So enthalpy is extensive. That's one thing. We'll talk a little bit more about that. The reaction in the forward direction is the same value. It just has a different sign in the reverse direction. And the third one is it depends on the state of the products. Okay, so let's take the first one here. Enthalpy is extensive. Okay, it means it matters how much you have, right? It matters how much you have. My son was going to make a birthday cake for his grandmother, great-grandmother actually. She was 96 years old. So he thought it would be great fun to put 96 individual candles on the cake. Okay, there's a reason why we don't do that, because enthalpy is extensive. One candle has so much heat, right? But when you actually put 96 candles on there, that is an awful lot. So he had a hard time lighting it. By the time he lighted it, was so much heat that it was seriously, the icing was starting to bubble and boil, and all the candles were melting, and it was just, it's really bad. Yeah, because he forgot, and Granny was going, my cake, you're ruining my cake, and all this, candle melting everywhere. That's why when you get to be 96 years old, they give you a 9 and a 6, right? There's a reason for that. Okay, because it matters how much you have. For example, look at these two equations. Can you tell what the difference is? What's the difference? Yeah, so there's twice as much here as the first one. Does everybody see that? Okay, when there's twice as much, now what happens? Yeah, twice as much enthalpy. So enthalpy is extensive. It matters how much you have. If I have twice as much, then I'm going to have twice as much enthalpy. If I have 96 candles, that's going to be 96 times the heat of that one candle. Okay, so that matters how much you have. Now this amount, negative, wow, was that exothermic or endothermic? Do you remember? Exothermic, very good. Heat's going out. So this is generating heat. So it's exothermic. So pay attention to the signs. It makes a big difference. It means something. So that's exothermic. This minus 91.8 kilojoules, since it's extensive, is tied very much to the coefficients in this equation. For example, negative 91.8 kilojoules is to 2 moles of ammonia. So if I'm going to make 2 moles of ammonia, this is how much heat's generated. Okay? If I make 6 moles of ammonia, you ought to be able to tell me how much heat's generated, right? Yeah, 3 times that. So this number goes with the coefficients in the balanced equation. If I use up 1 mole of nitrogen, I'm going to produce minus 91.8 kilojoules. If I use up 3 moles of hydrogen, I'm going to produce minus 91.8 kilojoules. Okay? So you could say it's a stoichiometric relationship then, isn't it? Yes, and perhaps a conversion factor we could write with that. Couldn't there be, right? Oh yeah, okay, that'll be fun. So this is very much tied. Now, if I have 4 moles of ammonia, why, that's going to be double that amount. It's going to be a minus 183.6 kilojoules goes with the 4 moles of ammonia. And the minus 183.6 kilojoules goes with the 6 moles of hydrogen. Okay, it's very much tied to our reaction and our coefficients in the balanced equation. Okay, so that's one. This one, the forward direction is equal in size but opposite in sign to the reverse reaction. Okay, so take a look at those 2 equations. What's the difference? Okay, one's negative, one's positive. What else? What else is the difference?
Oh, it's the reaction. One's like decomposition, one's a combination.
Does everybody see how we reversed it? What does it mean to reverse? Well, if it was a product and I reverse it, doesn't it become a reactant now? Yeah, and if it was a reactant and we reverse it, it now becomes a product, doesn't it? Okay, so you see how we reverse the reaction? You want to, okay, so another word would be flip. If I say flip the reaction, here's the reaction and I say flip it, does everybody see how that would mean the same thing? So are we okay if I say, hey, we're going to flip the reaction? That means we'll reverse it. Products become reactants, reactants become products. Are we okay with that? All right, so we flip the reaction, and when you do, does the number change at all? No. What's the only thing that changes? The sign. Okay, so we need to remember that. The sign has changed, but the amount of heat is still the same. Okay, here we have something going on. What's the difference here?
Like the number?
Okay.
Oh,
Ah, so do you see a difference in these 2 equations? Yeah, what's the difference then? One's a liquid and one's a gas. Okay, so we haven't really paid too much attention to the phases, the states, but we need to do that now because it makes a difference. Okay, it makes a difference on the state of the reactants and the products. Because don't you have to add heat or take away heat when we're changing from one state to another? Right? Okay, so let's take a look at this. This is negative, so we know that means exothermic, right? So this much heat is being produced with this equation. But now, not as much heat is being produced with this one. Not as much heat. Whoa, where did some of that heat go? Where did that enthalpy go? That's right. It went here to change this phase from a liquid to a gas. Does everybody see that? So it makes a difference. Okay, so those are the 3 truths of enthalpy. And we're going to be able to use those as we go along in the rest of the chapter. So far we've talked about what energy is. We've talked about the signs of energy. We've talked about what enthalpy is. And we understand the truths about enthalpy, right? Okay, so energy, signs, enthalpy. We've talked about what that is. Well, now let's talk about how we can use it. Okay, so let's talk about that. How can we use enthalpy? Okay, well, guess what? We get to use enthalpy in stoichiometry. Yay! Yay, we get to do that again. All right, well, you guys know stoichiometry. Okay, now, remember in stoichiometry, everything, the given, all goes to what first? Moles. And then we do mole-to-mole ratio, and then back out. Okay, so in this case, when we're doing stoichiometry with enthalpy, we're going to be using heat. Okay? Now, instead of the mole-to-mole ratio, it's going to be a mole-to-enthalpy ratio. Mole to enthalpy instead. Because didn't we say enthalpy is extensive? And doesn't extensive mean how much we have? So don't we have to tie that then? How much we have? This is minus 91.8 kilojoules goes with the 2 moles of ammonia. So we're going to do a mole to heat ratio. All right, so let's talk about some conversion factors that we can get from the balanced equation with the mole to heat. What are some conversion factors I can get from moles to, our coefficients and heat? What are some of those in that first balanced equation? Okay, so 3 moles of hydrogen. And we take that to, okay, and 2 moles of ammonia. Let's use heat. How could we do it with mole to heat? Can I just write minus 91.8 kilojoules? Perfect. 3 moles of hydrogen to minus 91.8 kilojoules. Okay, so what's another one?
2 moles of nitrogen.
2 moles of ammonia.
I'm sorry.
No, that's okay. I knew what you're thinking. And
Over negative 91.8.
perfect. Okay, what's another one?
1 mole of N2
Okay.
nitrogen is negative 91.8 kilojoules.
Okay, and you can flip these around, right? We can also write the other one, which is a minus 91.8 kilojoules, is to 1 mole of nitrogen, right? We can write that one. We can write this one, minus 91.8 kilojoules is to 2 moles of ammonia, right? And can't we write this one too? Minus 91.8 kilojoules is to 3 moles of hydrogen. Okay, so you see where we got all those conversion factors? Okay, so now let's see if we can solve this problem. How many grams of nitrogen should be used to produce 1250 kilojoules of heat? Okay, so 1250, produce 1250. What kind of sign would that be? Produce, the system produces, so that would be negative, right? Because it's coming out, negative. The system, you have to think about it from the system perspective. So it's going to be exothermic, right? Yes, and heat from the system to the surroundings. Okay, so this would be a negative, you always have to double check all the signs, a negative 1250 kilojoules of heat. Now, I'm going to use my mole to heat ratio. So if I've got kilojoules on top, wow, we have to decide which one of these conversion factors is going to work for me. So if I have kilojoules on top, what am I going to put down here? Kilojoules on the bottom, right?
91.8.
Okay, so we're looking for nitrogen, so I have to put nitrogen. So which one of these is going to work for me?
1 mole of nitrogen.
This one, right? Okay, so that's the one that has the kilojoules on the bottom. Notice it's still negative 91.8, 1 mole of nitrogen, which is fine because the negatives do cancel out and we get positive, which is what we want for positive grams. Okay, so my units cancel out. Now I've got 1 mole of nitrogen, but what am I looking for? Grams. Okay, so 1 mole of nitrogen on top. Guess what has to go on the bottom?
1 mole.
Okay, mole of nitrogen, and we're going to what? Grams of nitrogen, perfect. And what is the grams to mole? What do we call that? Conversion rate, molar mass. Where does it come from? Periodic table. So we look it up for, does everybody see it's going to be 28, not 14? There's N2, right? So everybody sees 28. Okay. And it's always in how many moles from the molar mass? 1. There you go. Okay, so my units cancel. Make sure I'm going in the right direction, and I am. So excellent. So if we do the math, we would get, what? 381 grams of nitrogen. Question?
I must have missed the first part. Where did that 1250 come from?
Comes from the problem.
Oh, okay.
Yeah, but notice it says produce.
Okay.
So that's a
what
negative.
made it negative. Okay, I'm like, where did that number come from?
Yeah, we were just working the first one. That's okay. All right, so you see how we did that? Okay, now let's go again. This time we start from 45 grams of hydrogen, and you got to go the other way. Okay, so see if you can work that one. You're starting with 45 grams of hydrogen. You're going to use this equation, and I want to know, hey, how much heat is that going to be? Okay, so see if you can work that. Hey, Sean, how's it going?
Good, how are you?
Good. So, lab today, yeah?
Yes.
Okay, so you ready to go? The gas laws? Mm-hmm. Mm-hmm. Yeah. So you ready to go? Studied all that? Ready for that quiz? Yes?
Yeah, I can catch up on it. Yeah.
All right. Okay. And then when we get there, we'll figure out who's partnering up with who.
Okay, yeah, no.
Because we had a drop, so.
Okay, perfect. Appreciate it.
So what's the first thing you have to do? Grams to what? Moles, right? Because our units cancel, right? Okay. So the first thing we're going to do is we're going to convert grams to moles. Right? Because that's what we do with stoichiometry, isn't it? Okay, and then after you go grams to moles, then what are we going to do? Instead of mole to mole, we're going to do mole to heat. Okay, so did we set up the mole to heat? Okay, do we make sure our units cancel? Uh-huh. Okay, so do you think we got it? Okay, you think you're missing some, or do you think we got it?
I'm missing.
You're missing something. Okay, check with your neighbor and see if you guys got the same answer.
Hey, neighbor. Hey, good neighbor. Neighbors.
What's the number that you put there?
That's what I looked over at my partner over there. I wasn't sure where to go to.
The equation.
Yeah,
Well, here it is right there.
that's the heat. So that goes the top right up there. Okay,
Yes,
I was
that
like,
whole big
what-
number.
That's what all right.
That goes right
Just put
there.
heat up there. It doesn't work that way.
Yeah,
Thank you.
and it's extensive, right? So it matters how much we have. So check your coefficients.
Two. So oh.
Because
gotcha.
that
Yeah,
comes
yeah,
from the
yeah.
equation.
Got you.
Right?
Okay, thank you.
Okay. Okay, so check with your neighbor to make sure you guys got it right.
Is this going to be negative 400?
Yes, it is. It is that number. Exactly. All comes from here.
It's not this number?
Oh, yeah, so it's gonna be, negative 480.
Remember, it comes all the way here. Okay? This heat comes from this. This is how we write the equation. Right? You always put it out to the side, to the right of the equation. You'll see that little h. That's where we get the number from. So you got to keep reading all the way to the end. It's all part of that. How's it going?
Well, just like something of those.
Yeah, okay.
I guess we start with
Yes, so that's a negative 1250. So we do the mole to heat ratio from the coefficients of the balanced equation, and then we change it to grams with molar mass. So we're now doing this one. So you're starting with 45 grams of hydrogen.
going backwards.
Yes, and so we're going to convert that to moles, right? You know how to do that with molar mass? And then we're going to do a mole to heat ratio, which is this number and the coefficients. Okay? How are we doing?
Final heat, the delta heat.
Yes.
And
Because this heat goes with that equation. It's like all part of it. Like we would just read it all the way across.
Okay, perfect.
Because that's how we write those thermochemical equations.
And then cancel out the moles, and that'll give you
Yes.
kilojoules.
You'll see grams to grams, moles of hydrogen. But be careful because this is extensive, right? It matters how much we have.
Okay.
So look at the equation. Do you have 1 mole of hydrogen or 2 moles of hydrogen? It matters how much you have. That number only can go with the 2. So that has to be a 2 there.
Okay.
Because doesn't it matter?
Yeah, that
This
makes
is not the same amount of heat for 1 mole as opposed to 2.
Yeah.
That's a different number.
Yeah.
So that number goes with the 2 moles of hydrogen. So you have to put a 2 there. Right?
Okay.
Okay. What was the step you thought you were missing?
I thought I was missing something like there.
Oh, no. Yeah, that's good. Yeah. It's a little bit easier with the stoichiometry with the enthalpy. A little bit easier. You're a little bit... Okay. All right, how we doing? Do we got it? Good. Awesome.
I've always wondered.
Mike.
What you said? Why?
I'm trying to record these so that I can put them in an online class. Yeah. So,
I didn't know
yeah.
if it was a biker, if it was somebody trying to run in here. I know she called, prison and call the police to come and save us. I didn't know
Yeah.
what it was. That's why
Yeah.
I thought it was your bike, but I wasn't sure.
Yeah.
Is it recording
It'll record me, yeah.
now? Right now as we talking?
Won't record you, but I'll cut that out.
She's gonna edit.
Hello, folks. I wish you luck.
She's crazy. I'm sorry.
Hey, I notice your quizzes have been good in lab. You are smoking it. All right, I know, but you got to translate that same thing.
I know.
I mean, you're good.
Because I've been waiting till the last minute until Monday to take the test, so I'm not going to do that.
Yeah.
I'm just going to take it Saturday and spend the whole day if I have to.
Yeah, take your time. Totally take your time. Okay. All right. So are we getting it? You got it? Grams to moles, that's molar mass. You did that. And then the mole to heat, that comes from the equation. And your units cancel? Perfect. That's it.
I did it wrong the first time.
Oh, did you? What'd you do different?
I don't know what I did wrong. I think I did. I guess I wasn't paying attention to the mole ratio.
Oh, but remember enthalpy is extensive and it matters how much you have. So you have to pay attention to that because, 1 candle versus 96 candles, that's a whole different story. So 1 mole versus 2, that's going to be double, Okay. All right, so has everybody got that? We paid attention to the coefficients, right? Remember, and it matters how much you have. So you have to get that. That is one equation. So with a thermochemical equation, this number goes with these coefficients. Okay, so we remembered that? All right, so you converted grams to moles, and then you did a mole to enthalpy, right? So what was your final answer then?
Negative 5.4.
Okay, does everybody got that? Yep. Okay, what was it again?
Negative 5.440.5.
Okay. And if you had a negative 5397, then you use a little bit more accurate molar mass, which is always a really good thing. Okay, so very good. All right, so now you know what enthalpy is, and we can use it. Well, the next question is how do we get that number? How do you get this number for that equation? Did you not get that number? Oh, okay. I'll show you. I'll show you after class. I'll step it out and see what. We'll look at what you did. So this question is what is this number? Okay. How do we get there? How did we get that number for this equation? Okay, that's what we got to determine. And there's 3 ways that we can do that. So that's what the rest of this chapter is talking about, is how we find that number. You know what it is, and you've used it. Now we got to find it.